Okay, example 2 then. So example 2, we're asked to sketch the index graph y equals 3 to the power of x. So again, your mind should be thinking about what is the shape of any basic index graph where the base is a and a is obviously bigger than 1. Well, again, all of these graphs cut the y-axis at 1, so mark it. They all have a horizontal asymptote, which is the x-axis. And the equation of that is y equals 0. And again, for negative values of x, the graph is very low down but never touches the x-axis. And as x gets less and less negative and more positive, it starts to rise sharply. So its shape again is something, general shape is something like that. Okay, and that's our graph y equals 3 to the power of x. And again, we can put brackets around the power because that's going to tell us how that graph will be transformed. So let's look at part B. Part B, we want to sketch the graph y equals 2 upon 3 to the power of x. Again, I'm going to rewrite that without the brackets around the 3 to the power of x. That's just 2 multiplied by 3 to the power of x. Now I'm going to put brackets around the power, and that tells us how the original graph is transformed. So you can clearly see that it's not an inside change, it's an outside change. And it's an outside multiplying change, which means the y coordinates are being multiplied by 2. So in the original graph, all the y coordinates multiplied by 2. Now, if we go to the original graph, so the y coordinate at this point is 1, it's being doubled, so it's going to be higher up, it's going to be a 2. Again, take this point here, there's the y coordinate, that is going to be doubled, so that's going to be way up there. So you can see it's going to rise quite sharply. It's going to be higher up overall, but it's going to rise really sharply into the positive values. So it's going to look something like the following. So it's going to cut the y-axis at 2, and it's going to rise more sharply. The horizontal asymptote remains the same as before, because remember, the only way a horizontal asymptote changes is if you shift the graph up vertically or down vertically. Any other transformation, that horizontal asymptote will remain unchanged. So that is the graph y equals 2 upon 3 to the power of x. Okay, on to the final one in example 2. We want to sketch the graph y equals 3 to the power minus x. So again, I'm going to put brackets around the power. So you notice the power is negative x. So in the original graph, the power was just x, 3 to the power of x. Now it's 3 to the power minus x. So it's clearly an inside change. And you know from before that an inside change means only the x coordinates of the original graph change. Now, the only way the x coordinates will change here when it's negative x is when you reflect the graph in the y-axis. So that's, remember, if the negative is inside, it's always a reflection in the y-axis, because when you reflect any point in the y-axis, it's only going to be the x coordinate that's going to change. So we reflect in the y-axis. So again, go to our original graph, there it is, reflected in the y-axis, so it's going to be high up for negative values, and then it's going to cut at 1, and then it's going to be low for positive values. So it's going to look something like the following. Like that. So it's going to cut the y-axis again at 1, and then the x-axis is still going to be a horizontal asymptote. And the equation of that asymptote is going to be, again, y equals 0.